Alright, this is one of those where we need a force diagram. So here's this sphere of styrofoam. I'm going to have two downs here. This is the force of gravity of the styrofoam. And then we got to attach some mass to this force of gravity of some sort of mass. And that should be connected to my big dot here. I'll make my dot bigger. We also have a force of buoyancy there. It's not moving, so we know the sum of the forces in the y direction equals 0. I have force of buoyancy up. I have force of gravity of the mass down. I also have force of gravity of the styrofoam down, and those all equal 0. I believe we're supposed to solve for force gravity of the mass, correct? So I will rearrange this and get force of gravity of the mass will equal the, if I move that over there, it'll be force of buoyancy minus force of gravity of the styrofoam. Okay, that's kind of a big deal. There's some other stuff I gotta get out of the way here. I hope I can fit it up here. The volume of the sphere equals, what is the volume of the sphere? This is something you just kind of gotta look up and, you know, be thankful we have Google and you don't have to go chasing through a book or something. 4/3 pi r cubed. Boy, I am just not good with. Well, I'll fit it in here, and you'll like it. 4/3, so 3 pi. Now, careful here. This is where kids make these diameters 50. We got to cut that in half, and we got to go to meters. I'm going to do that all in one fell swoop here of 0.25 meters. But don't forget to cube that bad boy. I will draw a box around this so we can kind of keep our stuff straight. And I am horrible at space management. How do I have a job here? I'm not quite certain. 0.065 meters cubed. That's the volume of the sphere. That's going to be important. If I take this equation that I circled and come down here, I'm after the force of gravity of the mass. Force of buoyancy I can replace with my buoyancy of the density of water. Sorry, I don't know why I did that. Times the volume of the water times gravity, and then I'm going to subtract off. This is the force of gravity of the sphere. Remember, mass can be substituted with density times volume. I did that a couple of videos ago. It's just kind of that P equals mv thing. If I solve for mass, it's going to turn into density times volume. So that's where that comes from. So the density of the styrofoam times the volume of the styrofoam, and gravity's in there. Okay, is that cool? I hope so. Density of water is that 1,000 kg over m cubed. I'm going to multiply that times the volume of the water. The volume of the water is exactly the same as the volume of the sphere because it will displace that since it's submerged. But by meters cubed, right? And then gravity is 9.8 meters per second squared. What's a kg multiplied by the meter per second squared? Yes, it's a Newton, so that's what I'm going to get there. The density of styrofoam, I thought they told us it was 32, yes? Kg per m cubed. And that volume of the sphere is the same because it will displace the same amount of volume of water once it's submerged. And by meters cubed, and now I have a 9.8 meters per second squared. So remember, why did these things turn colors on me? I've got a blue and I have a red. You got to do those numbers first. Did I do these? I think I did. So the blue side is going to be 637 newtons. Remember kg times ms squared. The red side is going to be 20.4, but it needs to be subtracted off. The only way you can subtract is if they're like units. And you're going to get 616.6 newtons. But they want to know mass. Oh my god. So why don't we just give me a little bit more space. This is the old W equals mg. I have W, I need m. How do you get m all by itself? Mass equals weight divided by gravity. The weight is that 616.6 newtons. Gravity is still 9.8. And you should get about a 62.9 kilogram out of that bad boy. Woo woo, woo woo. Physics is fun.